Hello and welcome to the Splunk app for behavioral profiling, an app which enables you to deploy easy detection of behavioral anomalies at scale in complex environments to highlight the specific entities which are affecting the resilience of your business. This is an app which could be used for any number of use cases, but today I'm going to be demonstrating one which is focused around service monitoring, where modern infrastructure, services, solutions comprising of many constituent parts such as microservices and serverless infrastructure, any of which could be creeping towards an issue, could compromise the resilience of the platform and bring the entire service down. And today we're going to be exploring how the Splunk app for behavioral profiling could pinpoint which part is creeping towards that issue before it does. The app itself has a three-level architecture, the first of which is behavioral indicators. These are essentially metrics of behavior for your individual entities. So today one of those metrics is going to be the average number of bytes out for a particular endpoint in your service. The second level is scoring rules. That's where we take the values of all these behavioral indicators and we profile them to understand which ones are anomalous. And then once we've deduced which ones of those are anomalies, score those, which takes us to our third level, which aggregates all those scores by entity to highlight which components, which entities that you're profiling are the ones which are behaving most anomalously and require further investigation. So the first thing you're going to be wanting to do when you first install the app is go to configure and make sure that you've got the requisite indexes required by the app. But other than that, all you need to do is go to deploy and click new indicator. The app itself has two different options for defining a new indicator. The first of which is guided mode. That's where you use drop-down menus in the workflow interface to create your behavioral indicator. The other is for people who are a bit more familiar with Splunk's search processing language, or perhaps would rather do something a little bit more advanced outside the realms of those drop-down menus. But today we're just going to be focusing on guided mode. So I'm going to click there. The app itself requires just one line of SPL to take your data into an anomaly-based detection. So what we're going to be doing here is entering that one line. I'm just going to point it at our service logs in our web server index. So I've searched that. We can now see all of the data points for the last day. Next, I need to pick the relevant fields that we're going to be using. The first of which is the entity field. That's the thing, that's the collection of things or people that we're going to be profiling. In this case, it's going to be the field that relates to my various different services. So I'm just going to go on URI, and that breaks down all of my logs by their particular service. Then I have to define any other important fields that I've got. So these are any fields that I might want to view as part of the indicator I'm building. All I'm going to do here in these web logs is I'm just going to take the number of bytes for each of those URIs that we've got in each transaction. So a very simple measure. Then go to next, define new indicator search. And leveraging this as an input, we now turn that raw data into our behavioral indicator. So here, what I'm going to want to find is the average number of bytes, and split that into a really short time span. Let's say 5-minute windows. Actually, let's say 10-minute windows. And then for each service, it's broken down the average number of bytes, and we can see these vary wildly from 4,600 at the very top right through down to 230. So that's our behavioral indicator. Next, I can click review and save new indicator. I'm just going to call this average number of bytes. And you can see it's essentially a KPI. It's just a metric of behavior by service. We're going to have this search run daily, although it's going to break it into 5-minute windows. And we can see here the search that's made below, as well as the backfill option here to have this search run immediately. Click build, and then we've done it. We've built a behavioral indicator in 2 minutes, roughly, I imagine. Scheduled that indicator and and created some KV data around it and run it immediately. And that's now going to run every day for us. But that's only half of the puzzle, right? So we've recorded how many bytes rather on average are being expended by each of these endpoints. What we want to do is find where there's unusual values, and this is where we might be showing that a particular service is experiencing some issues. Maybe there's actually a security incident. Maybe something's being removed from it. So what we want to be doing for that is highlighting the anomalies. So there's two options for our scoring rule mode. The first of which is entity group mode. That's where we treat all the entities as the same, all the services the same, and just find which are unusual values across the group. The second is entity specific rule. That's where we create a baseline for each entity specifically and find where for a given entity it's behaving differently to how it used to behave. For simplicity's sake, we're just going to use the first option here. So I'm going to create one rule for across all of our entities in terms of what is or isn't anomalous. So created that, we can see that our behavioral search that we've just created is populated here, and we have to now select the scoring field, which is going to be average bytes that we've just created, and now the criteria. And for entity group rules, there's three different options. The first is the most simplistic, it's conditional. That's where we say, if the average bytes is over 1,000, treat it as an anomaly, let's score it. The second is more complex, it's standard deviation based, so it says if there's 2 or if there's 3 or if there's however many you want standard deviations away from the average, then treat that as an anomaly. And the third is machine learning based. It's based on Splunk's machine learning toolkit, and it retracts which ones are anomalies. And we're going to be using that today. So I click ML anomaly detection, click next, and now we can see this search is building. And what it's done is it has defined, we can see our data here, it's put it in a nice multimodal distribution. So most of our values are are underneath 10K average bytes, and it's produced for us 3 outliers up at the very top here. Without us having to input anything, we've just run a machine learning based search here without having to know anything about machine learning. We can change the profile of the data if we want. Auto runs all the available distributions and picks the best one, and we can change the outlier threshold if we want more or less in terms of outlier numbers, but I'm just going to leave it there for our 3 outliers. Click next, and then score those outliers. So now we've got the outlier logic determined. What we're going to be doing for our anomalies is picking what is defining how much they're going to be scored by. So you can see our top value here is 4,600. So what I'm going to do is click attribution value times scoring field. So that's our scoring field for the very top, and just times it by a really small value. So we're going to have 0.001. And what that does is it baselines my search where a really high value would be, actually let's make it 0.02, where a really high value would be nearly 100 attributed for it, and a lesser value would be all the way down to 1. So we can see here we've got our highest value is 4,600 bytes on average, but our lowest anomaly value is 38,000, and you can see that's why they've got 77 and 93, because we've times it by this attribution value. So again, we've already completed that, so I'm just going to call this anomalous high bytes by service 10-minute window. I'm going to get this search to run daily as well, much like our indicator search, and then I'm going to run that backfill. And again, we've now created both a behavioral indicator and an anomaly detection rule on top of that, which now defines for us every day which services had a high number of average bytes in the 10-minute window, something that we should be looking at. But that in itself isn't necessarily going to find you which services require viewing. And that's why the Splunk app for behavioral profiling aggregates this with all the other rules that you've made to highlight which services require the most attention. So if I click on that drop down, we then get through to the entity behavioral score dashboard. We can see over a given window, whatever we want that window to be, how our scores are spread across all of our entities, what that distribution looks like. This is exactly what we want, a nice exponential distribution where 1 or 2 things are highlighted and everything else is treated as the same, so we can know that there's a few things that we need to have a look at. And then we can see here really the crux of the app, which is a prioritized list of entities for us to go and have a look at. So we can see our top one here is login, our login service. It's got a high average response time and a high max bytes out in a 5-minute window. Because the articles actually correlates with the rule that we just set up, anomalous high bytes by service, 10-minute window, as along with another few other rules that have been set up there. And then if we go further down, we can see how many rules have triggered in general across the entire group, how they split both in terms of score assigned and number of times triggered. So for example, here we can see our unusually low number of users requesting probably needs to be tweaked because it's producing both a large score and a high volume across all of our entities. But it could equally be that what we take from this is that we need to increase the score assigned by anomalous high bytes if we think that that's a rule that we want to be having more of a bearing on our models. But anyway, if we return back to our list of prioritized entities, what I can now do is go on the top one. So for example, login. Click on that, and now I get an individual investigative dashboard where I can see what does this service look like over the last 4 weeks? Is it always an issue, or is this just a rare spike? Where does it sit percentile wise and in raw value compared to all of our other fields? When did it trigger all of its rules over time, and how much was triggered? And then if I click on one of these rules, so for example, high max bytes out 5-minute window, and scroll down, I get both the raw events that triggered. So we can see I did have quite a high max bytes in a lot of 5-minute windows over the last day. And then we can see the individual raw attribution values it's had here. So it's only had one, which was 50, because it had 4,125 at a given point in that day. Awesome. So and if we wanted to go and have a look at the raw data, we can click on that view there, and then we go through to the raw underlying data, and we can see how it's behaving, right? So just through that, we've managed to go from at the very top, having an idea of what we want to track, having an idea of a particular behavioral indicator, building and scheduling that indicator, building and scheduling an anomaly detection scoring rule, and now having a prioritized list of entities for us to go and investigate. I can mark that login service as reviewed if I want. If I wanted to remove it from all of our searches, because I think it's going to be creating a lot of noise, I could click allow list and allow list that particular service, but I won't do that on this occasion. If we refresh here, we can see that we've marked it as reviewed successfully, something we can then pivot off if we just want to see the ones we haven't reviewed today. And finally, now as I go forward in the app, I can ensure that all of my rules are behaving effectively by clicking on a given search and seeing how it's performed over its lifetime, checking that its search runtime hasn't gone too high, checking that it hasn't produced too many events, too many different fields, checking what its cardinality is. And these are all views which allow me to make sure that a search is performing well in production, both for particular indicator searches and for scoring rules. And if you'd like to get started with the Splunk app for behavioral profiling today, it is available on Splunkbase.